Hello, my dear children. Welcome back again to the physics class. So you all know in the last class we have started a new chapter called machines, where I explained about the definition of machine, I explained about the functions, or you can say uses of machine. There were 4 functions, and I hope you have understood and revised from your book as well. So today we will be doing some technical terms, okay, which are related to a machine. So these technical terms has to be kept in your mind, because we will be using these technical terms or the terms time and again, okay, and in doing so you must not get confused what we are relating to or what we are trying to say or convey. All right, so now I'm going to teach each and every technical terms one by one. So the first technical term that we are using in machine is called load. Now what is load? Load is the resistive force or the opposing force which has to be overcome by the machine. For example, if you have a stone here, a big boulder which you are not able to push, but if you use a long rod with the help of a small stone here, you can easily now push this stone. So this heavy stone is the load, okay, which has to be overcome by this machine here. The machine here is this rod. Are you getting my point? Yes. Similarly, if you are drawing a water from the well, and if this is the pulley and this is the bucket of water, okay, and you are applying the force here to lift the bucket upward. So this bucket is the load here, represented by capital letter L. So load is represented by capital letter L. So this load has to be overcome by this machine with this help of this force, okay, understand? So this load is called the resistive force or the opposing force, which has to be overcome by the machine. Machine le overcome गर्ने force like के भन्छ load. So load is also a kind of force, don't get confused here. So this force which is opposed or resisted by this machine is called load. Okay, the second term is the effort. So to overcome some load here, to overcome this stone, that is load, we are applying a force here at this end of the rod, and the effort, that force is called effort. Similarly, when you are drawing the water from the well here, you are applying a force F here in this end of the rope, so that is your effort. So effort is denoted by the capital letter E. Effort is also the force, okay, but this force is applied on the machine. So now see, let us compare these two. So both load and effort are force, okay. So load is the force which has to be overcome by the machine. Effort is the force which is applied on the machine to overcome the load. See, take it again. Load is the force which has to be overcome by the machine. And you know a machine cannot work by itself. So you have to do some work on the machine. So that work that you are doing is with the help of this effort. So effort is the force which you are applying on the machine to overcome this load. Alright. So see, effort is applied on the machine. Now after you apply the effort on the machine can overcome this load. So your load ma गर्ने काम कसले? Machine ले, okay, is done with the help of this force which is called effort. So effort you apply on the machine, load is the force which is overcome by the machine. So these are the two first technical terms which you have to understand properly. Okay, if you don't understand the concept of load and effort, you might get confused as we progress in the chapter, all right. So number 3 is your mechanical advantage. denoted by the letter MA. Now what is mechanical advantage? Now see, whenever you are doing some work with the help of machine, it should be convenient, it should be easy, isn't it? So how efficiently the machine is going to help you to do the work is measured by this term called mechanical advantage. So mechanical advantage ले चाहिँ के भन्छ, मसिनले चाहिँ कतिको चाहिँ तिमीलाई काम गराउन सकाउँछ. That is what we call mechanical advantage. Okay, so mechanical advantage is nothing but the ratio of load to the effort. Okay, so mechanical advantage is the ratio of load to the effort. Did you get here? Okay, so now see, you must understand that this load and effort, they are the force, so their unit will be Newton or dyne. If you are talking about SI, it will be Newton. If you are talking about the unit of force in CGS, it will be dyne. So unit of load and effort will be Newton or dyne. But here you see that mechanical advantage, it is the ratio of load to the effort. So it means that if you're talking about Newton and Newton as the unit, Newton and Newton gets cancelled, leaving behind no unit. So what I'm trying to tell you is that mechanical advantage do not have any unit, since it is the ratio of two same physical quantity, that is force here. Alright, is that understood? Okay, now let's go to the next page here. In the next page, now what we are going to learn is the trick to remember mechanical advantage. So we saw that mechanical advantage is the ratio of load to the effort. So if I write all the letters together, I'll get MALE, male. So this is a trick in which you can remember the relation of mechanical advantage with load and effort. Alright, just remember this word, male. Now the fourth term that you have to remember is velocity ratio. What is it? Velocity ratio, denoted by VR. Now what is velocity? So velocity means something is moving with respect to time, isn't it? Something is moving with respect to time. That is what we get. That is when we get velocity. So here we are finding velocity ratio. A ratio, it's a comparison. So by the term here itself, it says that it is a ratio of velocity, isn't it? Ratio of two velocities. Ab kosko velocity bhandakheri chai velocity ratio is the velocity of velocity of effort, that is VE, divided by velocity of load, that is VL. So he get that velocity ratio, it is the ratio of velocity of effort to the velocity of load. So here, see, again you can take the example of drawing water from the well. So here I have the pulley, here you are applying the effort, and here you have the bucket of water, which is the load. So when you apply effort here at this end of the rope, the effort moves downward, means it is covering some distance in certain time, isn't it? Similarly, this load will also shift upward, means it will cover certain distance, that is distance moved by the load with respect to certain time, isn't it? So here you see that the load is moving similar with the effect of effort, isn't it? So you get this relation, VR equals to velocity of effort to the velocity of load. So here you see that velocity of effort is given by the displacement of effort divided by time, because you know velocity is equals to distance by time. So you can use that concept here. Similarly, the velocity of load, this load, this load which is moving upward, means it is covering a certain distance. So that if that distance is dl and the time taken is t, so I'll get dl by t. That is the velocity of what? Load. Okay, now here, so what do we get here? We got that VR equals to velocity of effort divided by velocity of load. and we got that velocity of effort is nothing but distance moved by effort divided by time, and velocity of load is nothing but distance moved by load in the time t. So therefore here I get velocity ratio. अब योलाई VE भनेको चाहिँ कति रहेछ, DE by T divided by VL, यो भनेको चाहिँ कति हो, DL by T here, isn't it? Yes, so T and T gets cancelled here, so I get velocity ratio is equals to distance moved by effort divided by distance moved by distance moved by load here. All right, so we got the second relation for velocity ratio. The first relation is here, velocity ratio equals to, this is the first relation, this is the second relation. Velocity ratio is equals to distance moved by effort divided by distance moved by load. All right, so you got two definitions for velocity ratio as well as two mathematical definition for velocity ratios, okay, which you can find in the book. So again, you see that velocity ratio, it is the ratio of two similar physical quantities, so it has no unit. So velocity ratio also has no unit. All right, so number 5th that we are going to learn today is work input. Now you know work, or you can say a machine cannot work by itself. You have to do some work on the machine. So the work that you are doing on the machine is called work input. What do you call it? Work input. Similarly, number 6 is work output. So when you are doing some work on the machine, machine will do some work for you. So the work done by the machine on the load is called the work output. Is that okay? Yes? All right. Now comes number 7, that is efficiency. Efficiency भनेको चाहिँ कतिको चाहिँ मसिनले काम गर्न सक्छ. Okay, now what is efficiency? Efficiency is again the ratio of the work done on the load divided by work done by the or on the machine. So efficiency is work, okay, output divided by work input. So efficiency is again the ratio. Now efficiency is denoted by or expressed, okay, by a symbol called eta. And how do we draw eta? It's just like n, but it has a small tail like this. So this is called eta. Okay, clear? So here I'll write eta, that is efficiency, equals to work output, that is the work done by the machine on the load, okay, divided by work input, that is work done on the machine. This gives my efficiency, okay, and this efficiency is usually expressed in terms of percentage, so I'll write multiplied by 100%. So this would be the relation to find efficiency of a machine. Now again, it is a comparison of same physical quantities, so efficiency also has no unit. So here we saw three things here: mechanical advantage, velocity ratio, and the efficiency. These are the three terms that we learned today, which has no unit. It has no unit. All right, now we will learn principle of machine. Machine चाहिँ कुन चाहिँ कन्सेप्टमा काम गर्छ? What is the principle on which machine works? So machine works on the principle of input energy equals to output energy, or you can write output energy equals to input energy. So this is the principle of machine. Machine works on this concept, this principle, that is work done on the machine equals to work done by the machine. But this is possible only for the machine which are ideal. Ideal machine means the machine which is frictionless, okay, and weightless. So what are ideal machine? Ideal machines are frictionless and weightless machine. But if I ask you, is it possible to have a machine which is frictionless and weightless? No, isn't it? So there cannot be a machine which is ideal machine चाहिँ हुँदैन यो त सोचाइ मात्रै हो concept मात्रै हो because you know that a machine cannot be weightless, it will have some weight, and a machine cannot be frictionless. Whenever some parts of a machine is moving, there will be some friction, so means that some energy will always be waste huncha. It will be wastage. Okay, so we'll have the next term, that is actual machine. So actual machine is the machine, okay, which has efficiency less than 100%. So actual machine ko चाहिँ efficiency के हुन्छ less than 100% हुन्छ. Okay, now why? Because there is a loss of energy. What is there? Loss of energy. Now loss of energy takes place in three ways. Number one is, now the machine is not frictionless. Some part of the machine energy is wasted in overcoming the friction. You will get this, you can find this in your book also. Okay, second one is the strings or any parts which are used in the machine is not perfectly elastic. हुँदैन. Number one is frictionless. You cannot just write frictionless elastic one, you have to elaborate also here. Okay, so I may ask you, okay, what are the reasons for the loss of energy in a machine? You cannot just like frictionless elastic one, you have to elaborate a bit. Okay, and number three is the parts of the machines are not perfectly rigid. एकदमै rigid चाहिँ हुँदैन. Understand? So these are the three reasons for the loss of energy excuse me, in a machine. All right, so today's assignment is to explain the term load, effort, mechanical advantage, velocity ratio, work input, work output, efficiency. Okay, and the next question is state the three reasons, okay, for the loss of energy in a machine. So these are the things that you will do today. Okay, now let's go to the next page. In the next page, what we are going to learn is we are going to see, okay, so now what we are going to learn is we are going to derive the relationship, okay, relationship between efficiency, that is denoted by eta, mechanical advantage, and velocity ratio. These are the three terms which we have learned, which has no unit. Now why it does not have any unit? Because it is the comparison or the ratio of same physical quantities. All right, so now to derive this relation, let me take a load L. So I am taking a load L, okay, and to overcome this load L, okay, I am applying an effort E for t seconds. So I am applying the effort on this load for t seconds such that the displacement of this effort is dE and the displacement of this load is dL. Is that okay? So from here I get work input. कति चाहिँ मैले काम गर्दैछु मसिनमा will be given by effort into displacement. We have learned this in the second chapter, that W equals to F into S. The same concept I am applying here. Work input equals to force into displacement. So the force here is E. Effort is E. So E into displacement is dE. Similarly, work output is load into displacement of load. So I'll get L into dL. Is it understood? Okay. So now let me move to the next page. So now, by the definition of efficiency, you know that efficiency is work output divided by work input. This is what we get from the definition of efficiency, isn't it? Yes. So or efficiency equals to work output. Just now I got the work output as load into displacement of load, and the work input is effort into displacement of effort. All right, or efficiency equals to, now let me separate this, L by E into dl by de, displacement of load divided by displacement of effort, or efficiency equals to L by E into this, I can rewrite this as displacement of effort by displacement of load. Okay, I'm just rewriting by taking the numerator to the denominator. Okay, so or I get efficiency equals to, now you remember the word MALE, that is mechanical advantage is equals to load by effort. So load by effort here is nothing but mechanical advantage into, you know, dE by dl. The ratio of displacement of effort to the displacement of load is nothing but velocity ratio. So I can replace this as 1 by VR. Alright, so now when I cross multiply, I get efficiency into VR equals to mechanical advantage. So this is the relation that I get. So the relation, the final relation is mechanical advantage is equals to velocity ratio into efficiency. So here I get one more relation to represent mechanical advantage. So now you can again define mechanical advantage in one more way, that is mechanical advantage of a machine is equal to the product of velocity ratio and efficiency. All right, yes, okay. So now one more important note has to be written in your copies. Okay, whatever the explanation that I'm doing here, you can write in your note copy also. You can note this explanation so that it will be easier for you all to do the revision. Okay, now you must remember that for an ideal machine, a machine which is frictionless, okay, and weightless, which is not possible actually, okay, for this, okay, for an ideal machine, okay, efficiency is always 100% and its mechanical advantage is numerically equal to velocity ratio. So this is possible only for machines which are ideal, but in actual practice, you know, there are no ideal machines, there are no machines which is frictionless and weightless, isn't it? So in actual practice, the mechanical advantage for all practical machine is always less than its velocity ratio. So mechanical advantage is always less than velocity ratio. This is the actual scenario for the machines, actual machines. So actual machine को चाहिँ mechanical advantage जहिले पनि velocity ratio भन्दा कम्ती हुन्छ. Mechanical advantage equal to velocity is possible only for the machine which are ideal. All right, and so we get that efficiency, okay, for actual machine is always less than 100%. So efficiency कहिले पनि कुनै machine को 100% हुँदैन. That is possible only if a machine is ideal machine. The ideal machine is not possible. You cannot have a machine which is weightless and frictionless. All right, so I hope you understood how we got the relationship, okay, so between mechanical advantage, velocity ratio and efficiency. Okay, if you see this derivation, this is what we call derivation. Sometimes in the ICSE it has come, okay, so you must also know how to derive this relationship between mechanical advantage, velocity ratio and efficiency. All right, so go through your book. Once you have completed watching this video, you again open your book, go through the book, read the book properly, okay, and if you have any confusions, do let me know. All right, so that's all for today. Thank you.